Section 4.3, solving quadratics by factoring. And now we're going to apply it to everybody's favorite subject, geometry. All right, so in this packet, let's head to the back. Here's some geometry problems on the last page. Number 59. It says find value of x. And they give you the area of the rectangle and the two length and width sides. So if you recall, the area is length times width equals area. Kind of written backwards this way because our quadratic is going to be on the left, and the number we're going to have here is going to be the value they give us is going to be on the right. And eventually we're going to get the 0 on this side, and everything will be over here. So laying out this way helps us to do this. You'll see another one when you do the triangle down here. Same way, I'll kind of write it backwards to the way you're used to saying it. So let's just put some values in. We know that the length here could be x plus 5, and the width is this value x, and it equals 36. All right, so we somehow have to get that 36 incorporated to the work over here on the left. But before we do that, let's distribute that x and see what we get. We have x squared plus 5x, and that'll equal 36. And then it's pretty easy to bring the 36 over by subtraction. So we have x squared plus 5x minus 36 equals 0. And when we're solving, we got to get down to 0 and get all the numbers on one side. All right, so now we're doing reverse FOIL. 36 factors. Let's see. Well, again, we've done enough. Now, hopefully, you see that 4 and 9 will get you the 5. So we build our binomials. Don't forget the equal 0. X, 4, and 9. The sign's negative. So then this sign goes to the big number, which is the 9. And now we said, I'll go over here, x minus 4 equals 0. And the x plus 9 equals 0. You split now. When you're solving, you're going to split your binomials and set both equal to 0. Again, to find out whichever one of these is equal to 0 to make this work. Again, we just, 0 is the only number that works when we're doing solving. We can't put any of the numbers there but 0. So we split it. This becomes, pretty easy to see that it's going to be x equals 4. With the 9 over, x equals negative 9. And if you were to check both those numbers, they'd work. They'd both work on that equation. But you can't have a negative length. So this thing is killed off. We'll put the 4 in, and we'll check it. 4 plus 5 is 9, and this is 4, so 4 times 9 is 36, so it works. Let's try the triangle down below. Area is 42. If you recall, the formula is 1/2 times base times height equals the area. Again, written backwards. Plugging in our binomials, it's 1/2. I'll use, this is 2x plus 8. Now, that's a little scary because we haven't seen those yet. But you'll see it works out pretty nice for us. Equals 42. Let's plug in the values. Now, when you multiply, you don't distribute this half to both of these, but you just multiply these two together. It gets incorporated into that, and it's gone. So 1/2 times 2 and 1/2 times 8, you'll see how that makes us an x plus 4. And this x plus 3 just stays. Equals 42. Okay, again, we're trying to get it equal to 0. I'll bring the 42 over, but I'll wait till I do my FOIL to this first. So I see x squared plus 7x plus 12. Now, I'm hoping you all can see how we did the FOIL. You may need an extra step in there. And then I'll subtract 42 from both sides, and I'll have x squared plus 7x minus 30 equals 0. This is key when we get to the 0 part. So now we can do reverse FOIL this. And let's see. I have 5 and 6, 3 and 10. 3 and 10 get me 30. So we have x, 3, x, 10. Sign's negative. This sign goes to the, this is negative, so this sign goes to bigger numbers, plus. And this is minus. Going over here again. So x minus 3 equals 0. X plus 10 equals 0. When I add the 3 and subtract the 10, I get x equals 3. x equals negative 10. Again, you can't have a negative dimension, so we'll just have to ignore that, use the 3. But please check it. So 3 plus 3 is 6, so I'll go up here, it's 1/2. Actually, the base, put in the base here. 2 times 3 is 6, plus 8 is 14. And 3 plus 3 is 6. And then half of 14 is 7. 7 times 6 is 42. It works just dandy. One more for us down below. These get a little trickier now, and the numbers get a little big. But it's good to have this application of some real-world actions going on here. So again, in this one, you have a picture of an original field here. The town has a nature preserve with a rectangular field that measures 600 meters by 400 meters. 400 by 600. Here's the original field. The town wants to double. They want to double the area by adding land. And to see if they want to add the same amount of land here and the same amount here to keep the rectangular shape. So these are going to be the same. All right, so first of all, you're doubling the area. Well, what's the area that exists now? Well, it's 600 times 400. I guess that's 24, just 4 zeros. 24, 240,000. And you want to double that. So I'll do that right now. It's times 2. It's going to be 480,000 square meters. Well, okay, so 240,000 was 400 times 600, right? Area, length times width. Well, now we got 480. We want to double this to the 480. Well, what are the dimensions now? Well, it's just 400 plus the x and the 600 plus the x. So this full dimension times that dimension. So there's a binomial there, a binomial here. There's some, or the product, sorry, is the 480. So I'll write that over here. So x plus 400 times x plus 600. Okay, these are the two new dimensions that we have by adding this, the x value onto both. Will equal now the double length of 480,000 square meters. As we've done the last two problems, we got to, FOIL this out and bring the 480,000 over. So x squared, you're going to have x, 600x, 400x, that's going to be 1,000x. And 400 times, this is going to be plus, just like we did over here, 240,000. That equals the 480,000. Now the numbers are huge, but as you're doing some of the factoring, sort of ignore the zeros, and I think you'll be able to be fine getting your factors at either 48 or whatever number you got. So just hang in there for a second before you panic. I got to bring the 480,000 over by subtracting, so 480k. I'm going to just shorten this up by saying 480k. The video can only be so long. So now I have x squared, I'm getting down there now, plus 1,000x. This is minus now 240,000. Equals 0. Hey, we're there. So now it's time to do the reverse FOIL. And you're kind of freaking out. That's a lot of numbers. Well, look over here. Where we start with 600 times 400. So just focus on the 6 and 4 to get to 2,400. And we need to get 1,000 in here. So this would work, 600 and 400, if we added them up. So that might be a possibility. But because this sign's a negative, this sign's got to be opposite. So these are going to subtract in one way. So it'll either be negative or positive 200. So these will not work. So I got to try some other factors to get this 24. So again, focusing on just the 24 part, it'd be 1, 24, 2 and 12, 3 and 8, and 4 and 6. We just took out the 4 and 6. This certainly wouldn't work. It'd be 240,000 times 1,000. We would not get down to 1,000. So let's consider, 100, 1,200, and 200. We subtract them because again we need a negative here, so we got to have opposite signs. 1,200 minus 200 will get us 1,000. I'm kind of liking these two numbers. So I'll have x and 200 and 1,200. Now, sign's negative. This sign goes to the bigger number. There's my plus, there's my minus. Let's just a quick check here. X squareds, 200 and 1,200 gives me negative 2,400. This is a positive 1,200x, a negative 200x. Yeah, I got the 1,000x. Now we split this, so x minus 200 equals 0. X plus 1200 equals 0. Again, this is going to give us a negative value. X equals negative 1200. Well, again, you can't have a negative length. So that's out. At 200, x equals 200. And there's our answer. Now, again, you want to check it by taking the 200 and adding it to the 400 and the 600. So we can do that. So 400 plus 200 is 600. And then 600 plus 200 is 800. You multiply these two numbers, do you get the 4,880,000? Yeah, you do. Just check it out real quick on your own. All right, good luck.